Hey everybody, this is Alex Merced. Welcome to another week of Gnarly Data Waves presented by Dremio. And this week we're doing another one of our awesome series of Apache Iceberg Office Hours, where you get to bring your Apache Iceberg questions and we'll bring our Apache Iceberg answers. But before we begin, we got a few pieces of messaging to deliver your way. And first off, I just always like to remind you guys the best way to understand the value of the Data Lakehouse is to get your hands on the Data Lakehouse platform that is Dremio. So if you head over to dremio.com, click on the test drive button, you can get hands-on and try out the Dremio platform at no cost, no obligation, so that way you can see why the Data Lakehouse and the conversations about the Data Lakehouse are dominating the data world today. So head over to dremio.com, try out test drive, and we'll see you there. Also, make sure to pick up an early copy of Apache Iceberg, the definitive guide, okay? We're constantly adding new chapters to the early release copy, so every once in a while, scan that QR code, see if any new chapters have been added. Again, slated for release early next year. It's going to be a jam-packed volume of Apache Iceberg data, so if you haven't read what's there already, I highly recommend doing so. Lots of great information and lots more to come. Okay, that's the new O'Reilly book, Apache Iceberg, the definitive guide, available in early release. And of course, every Tuesday, we got many great episodes of Gnarly Data Waves coming. This week, we're doing Apache Iceberg Office Hours. Next week, we're doing Simplifying Data Mesh with Dremio's Open Data Lakehouse. The week afterwards, we're talking about Dremio and DuckDB and how the synergies when you use them together, ELT, ETL, and the Dremio Data Lakehouse. And it's time for an even easier Data Lakehouse. Learn what's new in Dremio, where we'll talk about new features on the Dremio platform. Also, if you're at any of these events over the next few months, make sure you stop by the Dremio booth, pick up some cool swag, meet some cool people. It's going to be a good time, whether it's Big Data and AI in Paris in September, Big Data London also in September, Coalesce by DPT in October, over there in San Diego, CDO over there in August, actually tomorrow, and then the TWI expert panel, which will be Thursday, August 17th. So check these upcoming Dremio events where Dremio will be. And with no further ado, let's move on to our feature presentation, which is Apache Iceberg Office Hours. So here, what you can do is you can put in your Apache Iceberg questions, which our panel will answer. Okay, our panel is made up of Jason Hughes, Director of Technical Advocacy here at Dremio. Myself, Alex Merced, Developer Advocate here at Dremio. Dipankar Mazumdar, Developer Advocate here at Dremio. Ajanta Bhatt, Open Source Software Engineer here at Dremio. Dmitry Bolajakov, Senior OSS Developer. And Scott Cowell, Software Architect here at Dremio. And if you have any questions, you want to put them in the Q&A box. And then basically after this introductory portion, we'll start, basically going through your questions, talking about, any questions you have about Apache Iceberg, about the architecture, about your specific implementation questions, whatever you like. Feel free to ask away. But before we do that, we want to talk about an important topic that is basically becoming a big part of the conversation over the last couple months, which is table format interop. So what do I mean here? About thinking about not necessarily, hey, I'm going to choose a format, and that is the format for all the things, but how do you deal with the possibility that you may have to work with multiple formats, and how do you make those formats work together nicely? Okay, and there's a lot of different approaches to this. Right now, sort of the main approach that you can implement today that exists is just basically using tools that support multiple formats. Okay, using Lakehouse engines such as Dremio that can support multiple formats. So that's one approach to having these formats play together. And now you're starting to see a conversation of people trying to create frameworks for interop. So there's basically two that sort of have been announced this year, sort of how they evolve and how they will, what their exact implementation details are still sort of ongoing news. But first there's Onehouse. So Onehouse is sort of the company that has a lot of services built around the Apache Hudi format. And they announced a project called Onetable, which we'll talk about, which aims to allow two-way interop between all the three formats. Delta Lake, or Databricks, at the recent at their recent conference, announced that with Delta Lake 3.0, there is a thing called the UniFormat, and essentially what it is same ideas to allow interop by writing sort of multiple copies of the metadata in different formats. Right now, in its current incarnation, allows you to basically write an additional set of metadata in Iceberg format, so that way you can read your Delta Lake tables as Iceberg with Iceberg-oriented tools. But it aims to also kind of provide that two-way between Delta and Hoodie and Delta and Iceberg down the road. And again, all these things are still very early on in their lifespan, so we'll see kind of how that space sort of develops over time. But let's just take a look at each of these sort of scenarios one by one. So first one is like using a Lakehouse engine to unite table format. So like in this case, allow your tooling to handle the question of what can you work with. And essentially, like for example, like let's say Dremio supports read write on Apache Iceberg, and it supports read on Delta Lake. So theoretically, let's say you use your Dremio platform to provide yourself with really lightning fast BI dashboards, but you also maybe do some ML work using Databricks. So you have some Delta Lake tables on your Amazon S3, and you have some Apache Iceberg tables from other use cases or other data you've received in your Amazon S3. And you would like to join this data together. Now, intrinsically, Delta and Iceberg are two different formats that aren't necessarily built to play together. But if you connect S3 to your Dremio account, you could basically use that Iceberg table and that Delta Lake table like they're just two tables in your data lakehouse, and then be able to join them together, just like you could join any data sets. And then you can create a view on those data sets, which you can then accelerate for your BI dashboards by using Dremio's data reflections. But in that case, you just don't have to really think about the formats. They're just two data sets, and you can join them like anything else, allowing you to kind of play with different sort of formats pretty easily. So again, using different types of data lakehouse engines that allow you to have that sort of cross functionality between table formats is one approach to sort of solving this problem. Now, as we mentioned, using Onehouse has this one table technology that they're working on. I think already you can kind of use it in their platform. They have talked about like it being sort of a separate repository in their most recent announcement after the Databricks conference, where they put out an article re-announcing Onetable. But that repo is yet to sort of be shown in a public space. But there is, they are open to networks and partners to help out with the project. So they're trying to develop Onetable as sort of a separate sort of community project versus sort of the Onehouse product. But again, Onehouse is like the hood. Basically, think of them as like the Apache Hoodie service company. So if you use Apache Hoodie, they provide services around that. And the goal of their Onetable project currently is to be able to like sync those tables that you create and sync their metadata as different formats. So it's either Iceberg or Delta Lake. And you can sync it to pretty much any source that there's existing connectors for, including AWS Glue. Okay, so in the case of a situation like, let's say you're using Dremio as your Lakehouse engine, you could sync that as Apache Iceberg metadata to your AWS Glue catalog and then read those tables into Dremio. So that way, if you have hoodie tables, which normally would not be readable in Dremio, you can then use this technology to then make them readable in Dremio by exposing that Iceberg metadata. Again, still a lot of the details and a lot of the implementation details are still to sort of be revealed, but we'll see how this project evolves as it evolves. So again, these are one of the big announcements. I assume there probably will be a few more in the future, just because I went back. There we go. Okay, and then we have Delta Lake 3.0 with their UniFormat. Essentially, the way this one's going to work at the moment, again, all of these are evolving projects, it's an evolving space. So this is why, table formats are just an exciting place to be right now. What happens here is that you would if you're using Delta Lake 3.0, theoretically, what you can do is you can write your Delta Lake table. And if you turn on UniFormat, which is a setting you would turn on, it would then, after writing your Delta Lake files, it would asynchronously write your Iceberg metadata. Okay, so keyword there is asynchronously. So essentially, it's not necessarily, both sets of metadata aren't one atomic operation. Okay, so basically, there is that sort of moment of inconsistency where your Iceberg metadata is not necessarily at the same freshness as your Delta Lake table if you're using sort of those both sets of metadata, since they're being written asynchronously. So something to keep in mind. But essentially, as I understand it right now, you do need to use the Databricks Unity catalog to take advantage of this feature. Okay, so essentially, if you're just trying to use pure Delta Lake open source without any sort of using Databricks as your vendor, this feature isn't necessarily fully functioning at the moment, because it does depend on some of the features they have built into their platform with the Unity catalog, which currently does have a Hive interface and an Iceberg REST interface, which then allows you. So if you're using the Databricks Unity catalog and you want to connect to those Delta Lake tables using external engines like a Dremio, you could use that Hive interface using Dremio's Hive connectors. And if you want to connect to the Iceberg metadata, they're exposing an Iceberg REST interface. They're using the Iceberg REST catalog interface to allow exposure to those tables. So that's sort of how it's working right now. Again, right now you can only basically you're writing to Delta Lake, and then it writes the Iceberg metadata. Right now, it doesn't have the reverse functionality, and it doesn't have this functionality for Delta Lake to hoodie yet. They say that's going to be on there, and we'll see how that project evolves. But regardless of which of these approaches or multiple approaches you use in order to be able to work with multiple formats, okay, there are certain things you need to think about always when it comes to considering what your options are and sort of where do you want to commit your resources for long haul, because sometimes these architectural decisions are decisions that you just can't go back on once you've made them. So things you want to consider is things like consistencies. Okay, so for example, if you're writing metadata asynchronously, which you run into the situation, what happens if someone reads metadata set number 2 before the set before, well, let's say update, you have update and update, and you've updated metadata set 1, but not metadata set 2, and a query hits metadata set number 2, you're not going to be grabbing consistent data, okay? And that can be a concern if you're really relying on that data to fuel things like BI dashboards or whatnot, especially when it comes to really time critical data. Okay, so thinking about how the interop is, in this case right now, this would sort of give you an edge when it comes to using the engine-based approach, because in that case, you're always grabbing sort of the freshest metadata, regardless of what format the underlying data is in, allowing you for sort of like that data freshness consideration. Okay, but consistency, so taking a look at how these things are architected to make sure that any queries are hit are using consistent data, and so forth. Vendor agnosticism. Okay, so basically, can I use these tools without necessarily having to marry myself to X vendor? Okay, right now, generally, there really isn't truly a true vendor agnostic situation. Like, if you're using an engine, you have to use that particular engine that offers you multiple engine support, which more and more engines are doing so. So that's a little bit less of a consideration. Right now, as I'm aware, the Onetable service right now is usable as part of the Onehouse platform, but as an independent thing, I don't think yet. Okay, I think there is talks of that being a thing, but right now it's you'd have to be using like sort of like the Onehouse platform. So there is a sort of a vendor attachment. Same thing with the Delta Lake 3.0 UniFormat, that right now you generally need to use the Unity catalog. So in that case, you're marrying yourself sort of to Databricks in taking that approach, which again, marrying yourself to a vendor can be fine if they satisfy your use cases and you foresee them satisfying your use case in the long run. But again, use cases change, situations change. So it's always good to kind of think about, okay, where can I make sure that I have the most ability to adapt as future context changes, and thinking about, okay, where are my sort of lock-in points, so that way you can think about how you implement them to make sure that you minimize the stickiness when possible. Okay, and then flexibility. Okay, so for example, like you'd want to have access to all the features of each data set. And one of the problems with like some of sort of like these multi-sets of metadata approaches is, like, for example, with the Delta Lake to Iceberg approach, what they are doing is, like, let's say you have lots of updates to your Delta Lake table. What it will do is it'll batch those updates and make one update to the Iceberg metadata. So you might have 10 new snapshots to your Delta Lake table, but really only one new snapshot to your Iceberg table, depending on the frequency of transactions. Now, what does this mean? Time travel. You're not going to have that flexibility of time travel with the Iceberg metadata, because you're going to have fewer snapshots than you would the Delta Lake table. Okay, and one of the best features of Iceberg is to be able to do like time travel and a lot of those features around that. So like at the end of the day, like you have to ask yourself, sort of like, what is it you're trying to achieve when you use like these interop frameworks? What are you giving up, and are the things that you're giving up the things that you need? Okay, so again, it's great to have options, but it's always important to sit down and think about sort of what you're trying to accomplish when you're trying to evaluate those options to see which one may fit your use case the best. Again, this space is a very fresh, very new. Okay, before basically it's still very much a conversation about like everyone wanting to, basically, if you just go back a year ago, this question was still, should we have a Lakehouse? now the question generally, the answer generally has been agreed upon that, yeah, everyone should have a lakehouse. Now the question is really sort of like, okay, well, what am I going to anchor my lakehouse in? Which one of these three formats am I going to anchor my lakehouse in? Probably you'll have exposure to multiple formats, but one of them is probably going to be sort of where your center of data gravity. And so that's kind of where we're at now. And then in order to help sort of, alleviate sort of the risk profile of that question, people are coming out with these interop solutions. Okay, I do think it's also kind of telling that basically you see the only of the sort of the three categories of formats, the only sort of camp that hasn't offered interop solution yet is the Iceberg solution, probably because a lot of people are using Iceberg. A lot of tools, support Iceberg. So it's like there isn't as much a need there. But it's an interesting space. I'm really excited to see it because I always like seeing people being able to use more tools more easily. So with that, we kind of end our conversation about table format interop. And now we're going to begin answering your Apache Iceberg questions with our Apache Iceberg answers. So I'm going to stop sharing now. And we're going to check out the Q&A box. So if you have any questions, make sure you put them in the Q&A box. Okay. So let me take a look at Q&A. So again, if you have any Iceberg questions, put them in the chat or the QA box. I'll give everyone a moment to kind of put any questions that they may have at the moment. And again, this can be about anything. This will be about how Apache Iceberg works, about, maybe you are implementing a Apache Iceberg data lakehouse and you're trying to think, okay, which catalog should I use? Or, what are the different considerations I have to worry about, like authenticating to different things? Any of these questions and all questions are valid. So while you guys put your questions in the box, I'm going to want to check in with some of our panel. Particularly, I want to check in with Dimitri, Ajantha, and Scott, and just kind of, since you guys are on the forefront of like development around Apache Iceberg and Apache Iceberg related projects, just kind of like to hear about any interesting things you'd like to talk about that you are working on or is upcoming that you'd like to mention. So, Dimitri?
So I'm mostly working on projectnessie, which is kind of like an add-on to Apache Iceberg. It has an Apache Iceberg catalog component and a separate open source server implementation. It's actually undergoing rapid development. It's very fast growing. And the coolest feature it offers is essentially managing your Iceberg. Nessie as a whole gives you the ability to manage your data as code as you manage code. Like whenever you use GitHub to check in your code changes, Nessie aims to offer you the similar functionality for managing your data the same way. Right now, it works best with Iceberg, Apache Iceberg, but we have plans to extend it to cover different table formats as well.
Yeah, that's definitely one of the things I love about Nessie, because like basically all it is really just capturing these like little metadata clumps. So theoretically it could work with anything, which is really cool. Now like now there's like the REST API for Nessie is like V1 to V2. What were sort of like do you know what sort of like the major changes from V1 to V2, or sort of like what was the major reasons for that sort of version change?
It was mostly kind of like a cleanup effort, essentially trying to define an API that is consistent and coherent end to end, so that we could, have something for version 1.0, sort of like that kind of quality. Because V1 was sort of like the initial, just to get things out, sort of API. V2 was more coherent vision. Functionally, they're mostly the same. So whatever you could, like, there is no change in the sort of like what you can do. It's more about like how cleanly you can do this, and just offering you a more consistent picture.
Awesome. And we do have a question that came in. How do you ensure that updates are not lost when multiple transactions happen in parallel? Is there a way to ensure that you are using the latest version? Now, for this question, I will pass this one off to Dipankar or Jason, if you want to answer sort of like, how do we maintain sort of like making sure that the Apache Iceberg is being querying to the freshest snapshot?
Sure, I can take this one because I know Dipankar's having Zoom video problems, which is always fun. So I think I don't know which, I think there's two ways to answer this. I don't know which one, but we have time, so we might as well talk about both. So the first one, I think related to, I guess let's talk about just Iceberg, is that when you're updating, so I assume you mean the same table for multiple transactions, Iceberg leverages optimistic concurrency control. So basically what happens is that, let's say I'm updating, so there's simple versions, right? Where like, hey, so you're saying specifically updates. Let's say I'm updating partition where key equals value 1 versus partition where key equals value 2. So it's pretty easy to tell that, hey, even though these two updates, I started update 1 and then I started update 2 and update 2 finished before I finished update 1. Well, it's pretty easy to see that those are actually two separate, like they can both succeed. So basically it'll leverage that conflict resolution, and so you'll be fine. So it's kind of similar to the way, Git style merges happen. But like if I go update, even the same file, right? So file 1, and I go change that, and then somebody else goes and updates file 1, and the same situation happens. Well, then basically whoever commits last will actually have their commit rejected. They'll say, hey, sorry, the conditions that you set out when you wanted to commit aren't valid anymore. File 1 doesn't exist because somebody else, overwrote it. Let's say, copy on write style update. So that's basically how it protects that. And when you say you're ensure using the latest version, it really comes down to that catalog and that, who did that first commit actually wins. Now, the second commit that comes in, they won't be able to succeed if logically if it can't happen. Now, basically what will happen if that is commit 2, we'll just say, they'll just need to go retry their commit, which often works. But obviously it's a very context dependent and operation dependent situation. Now, I think the second way to really address that question, I'm not sure if maybe this is the way you were going, but especially with regards to the presentation that Alex just did, is around the kind of interop formats. And so when you say, when there are multiple transactions that happen in parallel, well, like, probably going like, for instance, with the uniform aspect, like, okay, you do multiple transactions to the Delta table. Now, how do you make sure that, you're seeing the same version in the Iceberg one? And the answer is that you can't, because it's asynchronous. I mean, you can go check, right? You can do a validity check. But even then, unless you're doing it as an atomic operation and you do a check and then you run your query, the change can still happen in the middle. So with any asynchronous operation updating state, when you query the two different versions, you can't ever truly be positive that at that exact point in time that they're equal. And so that's obviously one consideration there. And that's a big one for any async state transfer or replication. So that's definitely something to be aware of there. Now, obviously, ensure the latest version in that situation. If having the absolute latest version is always the requirement, I'd say go to the primary one. Go to the one that you're writing, right? Which your uniform is datalake. I think for today, for Onetable, it's only hoodie. But again, they're in theory doing the rest. But again, it's early, as Alex mentioned. So I think that's the main considerations there, is that if you always need up to date, I would go into the one that you actually write against, kind of a read replica kind of a situation, right? Like, what's your source of truth? And then for ones that are less time or less freshness sensitive, right? If I'm analyzing 10 years of data, the last 5 seconds doesn't have as much of an impact if I'm looking at it in aggregate. So for use cases like that, it can still make sense to use that kind of read replica, the kind of async replicated version.
Dimitri, I see your hand up. Did you want to add something?
Yes, thank you. Yeah, I just wanted to quickly mention that in the scope of projectnessie, that is actually one of the features that Nessie offers if you're working with multiple tables. Traditionally, if you just have an Iceberg table, you can sort of make your changes to one table, and if there are concurrent committers, then one of them wins and the other one has to do like an optimistic retry. What Nessie actually gives you is that it kind of extends that paradigm to include multiple tables. So, for example, if you're reading or if you're making changes to 2 tables at the same time and you want to keep them consistent, Nessie can actually offer you this capability, because the state of the catalog is tracked across all tables that are managed by Nessie. So even though you still have to deal with optimistic retries if you have multiple concurrent updaters, at least each state actually gives you the ability to, or ensures that the data in all tables at that particular point in time is actually consistent with each other, right?
Very awesome. And so multi-table transactions is definitely a very, very awesome use case for the Nessie catalog. And right now, the Nessie catalog is really the only catalog that gives you that feature. Not only just multi-table transactions, but multi-table rollbacks, multi-table tagging. So it's a really neat feature. Now, going back to sort of like checking in what everyone's been working on, Ajanta, what have you been up to these days?
I'm actually recently working on the partition stats feature at the Iceberg. I have opened a PR for formalizing the spec. To give some background, the Iceberg will store the statistics information like each column level from whatever present in the Parquet or ORC file in the manifest files. Then on top of it we have manifest list, and also we store table level statistic information in the puffin format. But it's not enough for all that time, and there are some query engines which uses a cost-based optimizer, and they require a partition level stats during the query level planning. So having this can improve the query planning to choose the right plan, and it can improve query performance a lot. Yeah.
Got it. Love that. Okay, so always love hearing about things that are going to get us even more performance out of the Iceberg. I mean, Iceberg's already given us great performance, but to hear there's even more coming, love it. Scott, let's check in with you. What you've been up to these days?
Yeah, so a lot of my focus is just on kind of integrating various aspects of Iceberg with Dremio. And so one of the big emphasis we've had over the past probably like half year or so is kind of continuing to improve on our ingestion into Iceberg tables. So one of the main commands there is copy into. And so we've got core copy into support. I forget which version it went out in. Maybe it's the 24. But kind of iterating on that. And so we've got a lot of great new capabilities we're looking to build into, kind of improving on text and JSON ingestion with more advanced capabilities there, looking at Parquet-based copy into ingestion in the future, also investigating more continuous ingestion type pipelines, improving upon that. So there's a lot of things that we're looking at in the future that are pretty exciting in terms of really enabling people to get data into Iceberg a lot easier. Since there's, there'll be a lot of ETL pipelines today where people are creating a lot of text, JSON, Parquet data. And sometimes it may be difficult to go change the ingestion at the source where they're creating those files. And so having something like a copy into serves as a bridge where we can help them then take the last step to get it into Iceberg. So we're pretty excited about that.
Awesome, love that. Yeah, definitely. It's always nice to hear more and more discussion of like Apache Iceberg ingestion. There's always like conversations always often so much times on like reading Iceberg tables, and there's so many ways to read an Iceberg table now. But now I'm glad to see there's more and more ways there's going to be to get data into those Apache Iceberg tables. Now we have a question coming in. How could I use a tool like projectnessie for an on-prem data lake? And I'll pass that one to Dimitri.
Projectnessie is essentially an open source project, right? Dremio obviously has a managed solution, but you completely free to use it. Like we publish Docker images, we publish just binaries as well. You can have that and deploy it in Kubernetes. I mean, that's kind of the standard nowadays. We have Helm charts, so you can run your own Nessie server. And what Nessie server gives you is the ability to manage your concurrent commits and metadata. And once you have that, you can actually configure your writers and readers to use the Nessie catalog at the Apache Iceberg level and connect it to your Nessie server. And there you go, you have it end to end.
Yeah, that's very cool. Like so Nessie is very flexible. It doesn't matter what you're using for your storage. So if you want to use object storage, you can use any of the cloud providers. You can use, because again, it's just storing the metadata, so it doesn't where the actual data is located. So very, very cool.
Yes, exactly. Yeah, it doesn't connect. The actual writing happens at the Iceberg level. So whatever Iceberg supports, S3, Azure, anything, Nessie will support as well.
Awesome. Then we got a question here. When data is loaded into Iceberg tables, how is row group size determined? Is there a way to tune that? I'll take that one. So it depends. Again, it depends on what engine you're using. So basically there are settings in Iceberg. So if you read the Iceberg spec on the Iceberg documentation, there are settings for setting what the row group size what the target Parquet file size is for for the Parquet writers. For sure, that's going to definitely, again, it's up to each engine to then honor those settings in the Iceberg spec. So, or in the that you read in the Iceberg documentation. So, but basically, you can use that to like tweak for sure how those Parquet files are written in, for sure in Spark. And then again, any other engine can then see those, because it's all inside the Iceberg metadata. All those settings can then see those settings and then also choose to write Parquet files using those settings as well. And then that you would use the yeah, it would just be like an alter table command to change the settings, or you can do it at table creation. But there's, and again, why you would want to change the row group size. I'm trying to remember what the default is. I want to say it's like 1 GB Parquet file size with a 512 row group. So basically 2 row groups per file. But again, you can tweak that depending on what your needs. And again, what your needs may be depends on sort of like what kind of queries you plan to hit. Like if you plan to have the data nice and well sorted and your queries are going to be really fine tuned, you might prefer more row groups, because then your readers can then prune or use predicate pushdown to kind of eliminate more of those row groups during query planning. And that'd be cool. But if you don't, if you are going to be reading more of the data more of the time, then you might prefer less row groups, so that way you don't have that metadata bloat occurring in the file for having the metadata for each row group in each Parquet file. So you can tweak that for sure, and it's in the Iceberg settings. Cool.
I think one other thing to add there as well is that, yes, I definitely agree with everything you said there. One other thing is that if you start out, as you mentioned, like, hey, I got some big queries that do basically scanning the whole partition every time. It's like, all right, well, yeah, then maybe bigger row groups is the right answer. But then if you start out somewhere big, you can always, experiment and try out with smaller row groups, especially with projectnessie, where it just becomes, a branch. You can also do branching with an Iceberg, and you can run both in parallel. But then if you do decide that actually a smaller size is better, you can always leverage basically rewrite the data files within a given partition across all the tables, whatever you want, to re-adhere to that new setting. So if you choose a setting, you're not necessarily locked into it. But obviously, the more data you have, the more that's going to cost and the longer that's going to take to rewrite. But just a consideration there.
100%. Okay, now next question is, if I use a Hive catalog on-prem, but would want to migrate to DremioArctic, is that possible? That one I'm going to send over to Ajanta.
Yeah, it's my favorite project. I have written down a catalog migration tool. It's a CLI tool where we can move a bunch of tables from one catalog to other catalog without copying any data. Yeah, I will share the link. Yeah.
Now on that, like, is there any like sort of things that people should consider when they think about different sources and different endpoints? So for example, like for example, like if you're migrating sort of on-prem catalog entries to sort of like let me think of an example, like into like a cloud catalog. Let's say I'm migrating to like from Hive to AWS Glue. So I migrate all those catalog entries, but all the files are still technically located in HDFS. Is there any sort of like considerations there or best practices?
It won't cause a problem now, because each catalog can read data anywhere it is present. If the previous data is present in HDFS, it can be present still in HDFS with the new catalog as well. We might have to work on a tool which is to move the actual data also from the HDFS to cloud or something, but it has some problem with the Iceberg metadata, because we store absolute path, right? So we can't just move around the data there. So if once we work on making the Iceberg metadata work with the relative paths, we can even do that.
Awesome. Okay, cool. Dimitri?
Yeah, I think there was some discussion about that in the Iceberg community chat, in the actual visual video chat, that people are aware of this problem. I think we might see some movement hopefully soon in terms of figuring out the relative paths versus absolute paths. And once that is settled, then it should be just a matter of time before tools appear that actually can move your data from one storage to another storage.
Awesome. Got it. Yeah. So yeah, no, that's definitely something I'm definitely looking forward to when you can move to like relative paths. Like there's, I think there's been one catalog that's preemptively sort of like implemented the current version of like the proposed spec, but the spec I don't think has been like adopted yet. So really, when it does, it's going to be exciting because that's going to make, yeah, like you guys said, like the data more portable, everything more portable, and that'll be really neat. Especially if I could just like just take a little folder with an iceberg table and just zip it and then just email it to somebody. That'd be cool. Okay, next question. Can I stream into iceberg tables and query those tables from Dremio? Okay, I'll take that because I just published an article on this subject. Okay, yes, you can, well, it's data at the end of the day, so you can stream that data however you'd like, assuming that you have the proper like libraries and tools. So right now, like there is a Apache Kafka Connect sync for Iceberg. There is Flink libraries for Iceberg. So any of these tools can be used for streaming. And then basically they should work for pretty much all catalogs. Okay, so I recently just published an article where you can actually set up a little local environment on your laptop and actually try out streaming from Flink into a Nessie catalog, into storage on Minio, and actually see it in action. So if you're interested in streaming, I highly recommend just kind of working through that exercise to see it at work. So again, imagine that you have a bunch of data, a bunch of events that are being collected by, Apache Kafka. You have a couple different options. Again, you can process that data from your Apache Kafka topic either directly into Flink. You could use a Kafka Connect, which can then integrate from point A to point B for you. Any of those tools, and then you have other platforms that that have discussed adding Apache Iceberg functionality. Like I think. If I remember right, I think Decodables mentioned that they were working on Iceberg. So Decodables, like the Flink as a service kind of company. Who's the other one that's escaping my head? I mean, Airbyte now should have or is about to have Iceberg functionality. Fivetran, and there's another company that's escaping my mind at the moment. But the point is, like, the options are growing, and you can generally most streaming platforms and streaming tools are expanding their reach into table formats. So any of those tools can be used to do that. And again, as far as like engines like Dremio, if it's in a catalog that we support, which again is pretty much all catalogs, basically Nessie, Hive, HDFS catalog, AWS Glue catalog, et cetera, like you connect those to your Dremio, you can now query those, deliver those to a BI dashboard. Doesn't matter whether that was batch ingestion or streaming ingestion, Dremio is going to be able to read that because again, it's always going to go to that catalog to figure out what the newest snapshot is. So whatever the latest commit is, that's what's going to be the result showing on that dashboard. So that was the long version of what it was a shorter answer of yes, you can.
And then a quick plug as well is that actually going even in more depth is one of the chapters in the Iceberg Definitive Guidebook, which Alex, I think you just finished the rough draft of. So it's up for review. So hopefully that'll be in the early release and available for anyone in the audience or anyone anywhere. Hopefully soon. So the next, as we work through the process, month or two-ish.
Yes. So much Iceberg stuff. So yeah, the point is like you can deliver the data from wherever you want to wherever you want. Like at this point, like tool support and the options that are available to you, pretty much you can satisfy pretty much. I can't think of a use case you can't satisfy with the available tooling for Iceberg nowadays. And again, it continues to improve. So really it's just a matter of sort of what is your goal, and then sitting down with sometimes you can sit down with the solutions architect who can help you kind of figure out what are the right pieces you need. And again, here at Dremio, we got plenty of solutions architects. We'd be glad to sit down with you and figure out sort of what you need for your use case. Let's see here. Let me see any other questions. Again, if anyone else has any other questions, put them in the chat and put them or in the Q&A box. And with that, I'll open up the floor if anyone has anything they would just like to bring up in the Iceberg world, or just an interesting like thought or thing they're exciting about, or anything Iceberg related. Yeah, I think we hit up like most of all the really kind of good, kind of cutting edge stuff. But I will just take a quick step back to that sort of like a couple of the things that are in the works, things that are not in Apache Iceberg yet, but there are proposals for different specs. So there's like two things that I'm aware of off the top of my head that there's like proposals for. One we already talked about, which was sort of the relative file paths, which is going to be really cool. The other thing is going to be multi-table transactions. Like, so right now, multi-table transactions you can do in Nessie. And again, Nessie goes beyond multi-table transactions, multi-table tagging. So you can just have one tag that covers your whole catalog. You can roll back one commit, and that rolls back all the tables in your catalog. So that functionality is pretty much still going to be sort of like exclusively in the Nessie, but from my understanding of sort of like the multi-table transactions proposals, mainly just for the actual like commit. So in the sense of being able to commit transactions to multiple tables. And I think that's the proposal that's still being kicked around and finalized and whatnot. So in the future, you may have more catalogs that can do that initial commit. That I don't remember anything in that spec regarding rollbacks or tagging. So really, like Nessie is going to be your option if you want to have sort of multi-table everything. But that's an interesting thing that's going on around the world, around the Iceberg world, and it's just always and there's also discussion of like sort of like DuckDB is talking about like adding even more Iceberg or adding Iceberg functionality natively into Iceberg and other tools that I'm trying to remember what other tools have made announcements recently, but they just keep coming. So point is like the Iceberg space is a good space. So if you're using the Iceberg tables, you're in a good spot. But I will give it one more moment for anyone to ask any remaining questions. And if not, we'll start kind of winding down. And again, I just want to remind everyone that we are doing this every Tuesday. It's Gnarly Data Waves every Tuesday, same bad time, same bad place. Make sure to head over to dremio.com and try out Dremio Test Drive so that way you can try the Dremio platform, which again, really high level of integrations with Iceberg. So just to kind of mention, like, it's not just can only just read and write Iceberg, but also data reflections, which is a very really interesting we did an episode on that a few episodes ago. Acceleration feature in Dremio uses Iceberg under the hood when it's creating like these sort of very smart not quite it's not exactly a materialized table, but you can kind of gives you the idea. And so I would definitely go back and watch that episode. But like, it's just basically Dremio really leverages Iceberg at every level to accelerate not just the data you have natively in Iceberg, but your data you have in any format from any connector in different ways. So really so I highly encourage you to go try out Test Drive, get hands-on with Dremio so that we can kind of see like that power, that engineering at work. But with that, we'll wrap up. I want to say thank you to Dimitri, Ajanta, Scott, Jason, and Dipankar for joining us again for Apache Office Hours. Always a pleasure to spend an hour with you guys.
Yeah, thanks, Alex.
Yeah,
thanks everybody.
Thanks, Alex.
Thanks.
And I will see you all next week for another episode of Gnarly Data Waves.